Hello YouTube, this video is about my Sudoku solver I've created last week, and it will solve Sudokus using backtracking. Um, I will explain these things shortly. So everyone, I assume a lot of you know what a Sudoku is. It's a popular puzzle, usually with a grid of 9 by 9 cells, and these are 4 by 4 cells, and it can be done with any square that has a square number of cells in it. So 4 is an integer square, 9 is an integer square, 16 is an integer square. So any square number of cells in the rows and in the columns will be fit for a Sudoku. This one is 4 by 4 since a smaller Sudoku will be easier to solve. This one is actually solved in 50 steps using backtracking. So in a Sudoku, it has the number of symbols that can fit into a row and in columns and blocks is 4 in this case, or equal to the number of cells in a row and in a column. Since uh, the goal of a Sudoku puzzle when solving it is to fit every symbol only once in every row, only once in every column, and only once in every block. And the blocks are 1, 2, 3, 4 cells in size. There are 4 blocks in this particular puzzle. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 cells in each block. So this is not a block, and this is not a block, depending on the variation of Sudoku you have. So in a 3 by 3, a 9 by 9 Sudoku, there's also 9 blocks. The number of blocks is always equal to the number of cells in each row and each column in classic mode. So the symbols I can fit in this Sudoku are the numbers 1, 2, 3, and 4. It will try to fit each symbol in each cell. So now onto the backtracking method. It will try to fit a 1 in this cell, actually in this cell, um, and it will fail since there's already a number here, and since that number uh, is already there in the original puzzle, it can't change this number, so it will move to this cell over here and change that number's value, that cell's value to the number 1, and that will work. So when it finds a solution for a cell, when that number actually fits, it will move to the next cell and try to fit a number in this cell, and then to the next cell and to the next cell. And when it finds a number that won't fit, when it finds that when it tries to fit a number 3 in this cell, it won't fit since there's already a 3 in this column. It will return to past decisions like the one it made here or here, and just increase the number that's already here by 1, and then continue to the decision that went wrong. And if that number that it will try to fit in here will actually fit this time, it will just continue with the next cells and change this number and this number and this number until it eventually finds another number that won't fit, and then it will backtrack again its history of decisions up until a point where it can actually increase a number without it not fitting. So when it actually fits. Let's see this algorithm in action. I can increase it. I can just move by this in single steps. The backtrack history will be shown on here in this text uh, in this text box, so we can see what decisions it has made. So the first step is to try and fit a number 1 into this cell, and it will work since there's no other 1 in this row, no other 1 in this column, no other 1 in this section or block. So it will add this decision to its backtrack history and move on to this square. So another step will show this occurring. We can see that it tried to put a number 1 in the first cell in the Sudoku, since that is row 0, column 0, and it will try to fit a 1 in that section. So this is cell in place row 0, column 0, and it had tried to fit a 1 in there, but it can't since there's already a number here, and then it will move on by default since it can't change this value at all. It's no use in trying to attempt that. The next decision it has made was this one in the row 0 in column 1. We can see this here, 0, 1, and it has put a 1 in there. So it remembers on which cell it has placed which number. Now this one here will fail on all three conditions. There's already a 1 in this row, there's already a 1 in this column, and there's already a 1 in this block. So this fails miserably. The next step is to try and fit a 2 in there, and this will succeed for the same reason. Then it will add this decision to the backtrack, and it has done so in step 3, in case you were wondering what this number is. And the number over here will be placed at the end of the backtrack. So row 0, column 2, and number 2 is added. I will continue to do this. Oh, you saw 5 over there. That's when it encounters a decision that won't work. So it tried to fit a 1 in here, and that couldn't be done since there's already a 1 here. It couldn't fit a 2 in there since the 2 over here in cell 02 already contained a 2. It can't fit a 3 in here since there's a 3 in this column, and it can't fit a 4 in there since there's already a 4 in here in this row. Then it attempts to place a 5, which is an illegal action since only the numbers 1, 2, 3, and 4 are allowed, and thus it has to backtrack to its past decision. And we saw it move back to this decision by it removing this decision. This was apparently a bad decision since this causes no number to be fit in here. It retracts that decision. It changes the number it placed there, so that it used to be 3, and it increases that number by 1. So this 3 will succeed, by the way. So it now will place this decision at the end again, but instead of a 2, it attempts to place a 3 at that position, and hopefully that will succeed. So this was already step 8 of 50. The next step is to attempt another 1 in this square, in this cell. It won't work. A 2 is fit, so now we can move on to the next row, and this decision is added to the backtrack. So 0, 3, 2, 0, 0 with the row, third column when starting to count with column 0, so and the number 2. The next this will fail. This will succeed, so it will add this decision to the end, as we can see here. Next step, next step, next step. Yeah, this is also something I wanted to demonstrate. This 1 over here indicates that there's only a single decision left at the left end of the backtrack, so that's this decision. When more decisions are added to the backtrack, this number increases, and we will only see the last 5 decisions, since that's the most interesting part of the backtrack, since this changes the most. So I'll increase the step count by 10, and another 10, and another 10. And in this part of the solution, we see that it has fit all the numbers into this Sudoku. It's now at the last cell to be filled, and this 1 will fail. There remains to be a 2 in this block, row, and column, so that it will increase this number by 1, and then step to this cell, which can't be altered, so then it's done. And we can see this happening here. So it has added to row 3, column 2, the number 2, which is this one, and this has a total of 8 decisions on the left side of the backtrack, excluding these 5. So in total there's 13 decisions. So we can now see it's done. The number of iterations is 50, the number of trials, and the max search depth is 9. So that's the number of decisions it has to retract, I suppose. It can solve any number of any size of Sudoku. So I can open another classic Sudoku of 9 times 9 cells, and it can also solve this one. If I step 10,000 steps, it's filled for 1/4. You can see this number. This one tries to place a 10 in here. That won't work since 10 is not a legal number. Since 9 is the maximum. So it will retract this number and go back to this decision and increase that one by 1. This 3 will not succeed since this one is already a 3 and that one is already a 3. The block contains a 3 too, so this will fail miserably. Next step, next step, next step. And 5 is a legal number in this one, so it will move on. Let's see him do another 20,000 steps. It's almost done. I know the number of steps this one generates. So 10 steps, 10 steps, 10. Yeah, it's done. Let's see. Yeah, it's done. So you can see it's got 42,000 steps in this one and a max search depth of 40. Now I want to attempt to solve the 16 by 16. Well, I made a mistake. I opened a text document of about 3.4 340 MBs. So that's a text file of 340 MBs. Well, I suppose that was the video. It can solve any number of any size of Sudoku, as I've told you already. You can download the source at the site included in the description bar. That's on my website, and well, hopefully you'll comment and rate this video since I'm interested in what you guys think about this. Have fun in exploring the code, and I will see you in the next video. Bye.